Welcome to Brain Vision.
Okay, so in this problem we have a flywheel that is rotating, uh, and we have to discover what is the average magnitude of the couple due to the kinetic friction. So we want to know the average magnitude that is generated by the friction. So first of all, let's begin. Remember that since this is a flywheel, this in this flywheel is rotating. She has a moment of inertia, and we know that for a rod, the moment of inertia is described as the mass of the flywheel, in this case, multiplied by the radius of rotation square. And we have this information here. So this is going to be 200 kilograms that multiplies the radius of rotation, which is 0.4 square. That gives us a moment of inertia of the flywheel equals 32 kilograms meters square. Okay, uh, what else do we have? We know what is the initial state of our system. So let's put here the initial conditions, okay? So the initial conditions of our system is the angular speed 1 equals 0, and the kinetic energy due to the rotation, the initial kinetic energy, let's call this K, is going to be also 0, because this is K1, because in the beginning of the system the flywheel is not moving. Okay, that's therefore we have the kinetic energy equals 0. Now we know that the total rotation angle goes from, let's put here, a theta 2 minus theta 1 is just 560 revolutions, which gives us a value of 1120 pi radians. Okay, so we know how much the flywheel moves in the angle. We know that the initial kinetic energy is 0. We know the initial angular speed, and we know the moment of inertia of the flywheel. Now, the second thing we must know is that we want to calculate the moment due to the friction. So remember about the work. So let's think about what we know of work. We know that work can be described as the variation of energy. So the energy when we go from point 1 to point 2 is going to be just the moment of the flywheel multiplied by the difference in the angle. So theta 2 minus theta 1. And this moment in the flywheel, this moment in the flywheel has two components of force. We have the 300 Newton force and we have the friction force. Therefore, we can say that this equation is just the 300 Newton force that rotates the flywheel minus the moment of the friction that is caused by the friction, that is generated by the friction. And that should multiply 1120 pi, as we already know. Okay, so now that we have the energy of this motion, and we also know what is the final state of the motion. So the final state, let's put here the final conditions. We know that in the final state, omega 2 is going to be equal to 2,400 rotations per minute, which gives us a value of 80 pi rads per second. We can calculate now the kinetic energy. So we know that the kinetic energy of the initial state is 0. Therefore, the kinetic energy in the final state, let's call K2, is going to be equal half of the moment of inertia of the flywheel multiplied by the angular speed square, the final angular speed square, which gives us half of 32 that multiplies 80 pi. So the energy, the kinetic energy, the final kinetic energy of the system is going to be equal, let me see, 1.01 065 times 10 to the 6 joules. Okay, so that's the average energy of the flywheel at the end of the motion. And according to the principle of work and energy, we know that the kinetic energy at the beginning plus the potential energy due to the work from point 1 to point 2 should be equal to the final kinetic energy. Should be equal the final kinetic energy. Therefore, the initial kinetic energy is 0 plus 300 minus m, I call mf, so it's the moment of the friction, multiplied by 1120 pi, that is equal 1.01065 times 10 to the 6. Therefore, if we calculate this, we will find that the moment due to the friction is going to be equal 12.77 newtons meters. And that's the final answer. So again, we just need to remember the principle of work and energy, which states that the energy at the beginning of the motion should be equal to the energy at the end of the motion. Therefore, we just need to use the work to describe the friction and calculate the final kinetic energy. Therefore, the solution is pretty straightforward. That's all. Thanks for watching.